In this section, we're going to look at Gauss's method, and his process is used to find the sum of a sequence of numbers. So let's get started. Use the approach in Gauss's problem to find the following sums of arithmetic sequences. A. We want to add 1 plus 2 plus 3 plus 4 all the way to 98. I'm going to call this sum S. So S is equal to 1 plus 2 plus 3 plus 4 all the way to 98. And we're going to write this backwards now. Gauss's method writes the sequence backwards. So we're going to have 98, then 97, then 96, then 95, and so on until we reach 1. Now we can add both of these together, so this gives us 2s equals, and in this case we have 1 plus 98, I know that's going to be 99. 2 plus 97, that's also 99, so you can see there's a pattern. 3 plus 96 is 99, and that's going to go down all the way till the end. All of these are 99s. Now the question is, how many 99s are there? Well, if you look, we have 1 through 98 numbers. So how many numbers would that be? That would be 98 numbers. We have 98 numbers that we're trying to add. So I know there's 98 of these 99s. So I can write the 2s is equal to 98 times 99. Adding 99 98 times is the same as multiplying by 98. So now we could solve for the sum by dividing by 2. Let's divide both sides by 2. And now we have s equals 98 times 99 divided by 2. Using our calculator, we have the sum is now equal to 4,851. Part B, I want to add 1 plus 3 plus 5 plus 7 all the way to 103. Notice this time we're adding all the odds. So let's start by letting this sequence have a sum of s. Again, we'll say 1 plus 3 plus 5 plus 7 all the way to 103. And we'll do the same method. We'll write it backwards. So s is equal to 103. The next odd that's backwards would be 101. And then 99. And so on until we go back to 1. Let's add this up. We have s, and s gives me 2s together. And now we'll have to figure out the sum. 1 plus 103 is 104. 3 plus 101 is 104 again. 5 plus 99 is 104 again. And of course this pattern is going to continue all the way to the end. And we're going to get 104 for each of these. Now the question is, how many numbers did we actually add? Well, look at this. If the number ends at 1, we only have one number. Again, if the number ends at 1, we only have one number. If the number ends in a 3, we actually have two numbers. If the number ends at a 5, there's only 3 numbers. If the number ends at a 7, there's only 4 numbers. So if you look at it carefully, you can find a pattern. Now think about it. If the number ends at 103, how many numbers are there? So look at it carefully, think about it for a moment, and see if you can figure out a way to find the number of numbers. Again, if it is 1, if it ends in a 1, we have one number. If it ends in a 3, we have 2 numbers. If it ends in a 5, we have 3 numbers. If it ends in a 7, we have 4 numbers. So there's some way to figure out the number of numbers. Okay, so here's the pattern. The pattern is we can take this and add 1 to it and divide by 2. Look at this sequence. If I take 1, add 1 to it, divide by 2, I get a 1. If I take 3, add 1 to it, I get 4. And if I divide that by 2, I get 2. Add 1 to 5, I get 6. Divided by 2, I get 3. So that's the pattern. So I'm going to take 103, add 1 to it, and divide by 2. And this will give me 104 divided by 2. And that is 52. So I know I have 52 numbers. That means there is going to be 52 of these 104s. So we can write this as 2s equals 52 times 104. I could divide by 2 now. And s is equal to 2,704. This is the sum of a sequence of odd numbers from 1 up to 103. For part C, we're going to add 8 plus 17 plus 26 plus 35 all the way to 890. To do this question, I have to find a pattern first. And if you notice, there's a difference of 9 from each one. So we're going to have to add 9 to get to the next number, add 9 to get to the next number, and so on until we get to 890. Now we're going to use Gauss's method again. Let's let S be this sum, 8 plus 17 plus 26 plus 35, all the way to 890. We're going to write it backwards, just like his method suggests, and we're going to put 890 first. And to figure out what is less than 890, we're going to subtract 9 because we're going backwards. This gives me 881. I'm going to subtract 9 again. This gives me 872. And that decreases all the way to 8. We're going to add s and s again. That gives me 2s. And then we'll add 8 plus 890. And that's going to give us 898. I'll add 17 plus 881. And that is 898, just like before. If you add 26 plus 872, again, you're going to get 898. And we're going to continue that pattern all the way to the end. We get 898 here also. Now, the hardest part is figuring out how many 898s we actually have. Again, I'll have to look for a pattern. If the number ends at 8, or if our sequence ends at 8, I only have one number. If it ends in 17, we have 2 numbers. If it ends in 26, we have 3 numbers. If it ends in 35, we have 4 numbers. And the question is, if it went all the way up to 890, how many numbers would that be? So we'll have to look for a pattern and pause the video, think about it. What is our pattern? So if you look at it carefully, hopefully you found the pattern. Here's our pattern. If we take 8, add 1 to it, and divide by 9, I get 1. If I take 17, add 1 to it, divide by 9, I get to 2. If I take 26, add 1 to it, divide by 9, I get the 3. And 35, I add 1 to it, get a 36. Divide by 9, I still get that 4. So that's the pattern. Now, how many numbers are there? If we end the sequence at 890, we'll use the pattern. 890 plus 1 divided by 9 and this gives us the number of numbers in our sequence. And I found that there are 99 numbers. There's 99 numbers in our sequence. So we can write 2s is equal to 99 times 898. And now we can divide both sides by 2. And our sum is given. Our sum is 44,451. Part D, we have a sequence here. We have 296, 293, 298, 297, and it goes all the way down to 2. So let's look for the difference between these. And it looks like the difference is subtracting 3. Each time we're subtracting 3 to get to the next number, and eventually we'll reach 2. So let's say S is this sum, 296 plus 293 plus 290 plus 287 all the way down to 2. We'll write it backwards again. So the first number is 2. Then since we're going backwards, we're going to add 3. The next number would be 5. The next number is 8. And we can continue the process all the way up to 296. I can add the two rows now. We have 2s is equal to 296 plus 2 gives me 298 plus, and 293 plus 5 is 298 again. And if you continue, you'll always get a 298 all the way down till the end. Now the question now is how many 298s are there? We'll have to look for a pattern again. You can see in part D they wrote it backwards, so they're trying to trick us here, but remember the sum forwards or backwards should be the same. So let's write it in the right direction. 2, the next number should be 5, 8, and then it should go all the way up to 287, 290, 293, and 296. Now if it ended in 2, how many numbers would there be? There would be only one number for that. If it ended in a 5, there would be only 2 numbers. If it ended in a 8, there would only be 3 numbers. Now we'll have to find a pattern. Pause the video and see if you can find a pattern. Okay, I think we have a pattern now. A pattern for this is adding 1 to the number and dividing by 3. You get 1. 5 plus 1 is 6. Divided by 3, you do get the 2. 8 plus 1 divided by 3, you do get 3. So that is the pattern. We're going to add 1 to 296 and then divide by 3. And this gives us 99. So there are 99 numbers in this sequence. So always look out for those patterns. Those patterns are going to help you figure out how many actual numbers are there in this sequence. This gives us 2s is equal to 99 times 298, since we know there's 99 numbers in this sequence. We'll divide both sides by 2. And there is our sum. Our sum is going to be equal to 14,751.